Hi, welcome to Math 120, Intermediate Algebra at Doña Ana Community College and NMSU, New Mexico State University. This goes along with Turner McKeague's Intermediate Algebra, first edition. Chapter 1, Real Numbers and Algebraic Expressions, Section 1.3, Arithmetic with Real Numbers. Alright, so to add two real numbers, if they're the same sign, so both positive or both negative, add their absolute values, and then attach their common sign. So if you add two positive numbers, the result is positive. If you add two negative numbers, the results are negative. Alright? If they have opposite signs, so you have a 2 plus a negative 3, subtract the smaller absolute value from the larger. And basically that says, ignore sign, absolute value, take the biggest and subtract the smallest. Now, is your answer going to be positive or negative? Attach the sign of the number whose absolute value is larger. So big minus little has the sign of big. All right, if they're the same sign, both positive or both negative, you add the numbers and then use that sign. Opposite signs, do big minus little, and then use the value of the bigger number in absolute value. Subtraction. If a and b are any two real numbers, then the difference of a and b, written a minus b, is given by adding the opposite. So if I do 3 minus 4, I could think of that as 3 plus a negative 4. When we're multiplying two real numbers, we multiply the numbers themselves in absolute value, meaning ignore the signs for now. It doesn't matter positive or negative, just multiply them. Now to take care of the signs, if the two numbers have the same sign, the product is positive, because a positive times a positive is positive, and a negative times a negative is also positive. But if the two numbers have the opposite signs, the product is negative. All right, so a positive times a negative is negative. If a and b are any two real numbers, as long as b is not 0, then the quotient of a and b, written as a fraction, a over b, is the same as a multiplied by the reciprocal of b. So think about this. Dividing by b is the same as multiplying by 1 over b. We'll use this property a lot when it comes to solving equations. So dividing by b is the same as multiplying by the reciprocal of b. Alright, order of operations. Most important thing you could remember in all of math. This forever and always will have this order of operations. And it comes in handy in other aspects as well. So when evaluating a mathematical expression, we'll perform the order of operations as follows. Begin with the expression in the innermost parentheses or brackets and work your way out. So parentheses come first. Simplify all numbers with exponents, working from left to right if more than one of those expressions is present. So always left to right, just like we read, just like we write, just like our number lines, left to right. Step 3, work all multiplications and divisions left to right, always left to right. Whatever comes first, multiply, divide, divide, then multiply. And lastly, we perform all additions and subtractions from left to right. And the way I remember this is PEMDAS. And a lot of people have heard of PEMDAS, but I like this writing of it best. Parentheses, exponents, multiply and divide are on the same level. So we go left to right, whichever one comes first. And add and subtract together on the same level, whichever one comes first, working left to right. Let's look at some examples. So we're going to simplify each expression as much as possible following the order of operations. 6 parentheses 1 minus 1 parentheses negative 5 plus 1 parentheses 2. Now inside these parentheses there's no operation going on. They're just real numbers, and so there's nothing to do with parentheses. There are no exponents. So we're going to multiply and or divide from left to right. 6 times 1 is 6. Minus 1 times a negative 5 is a positive 5. 1 times 2 is 2. So I took care of all the multiplications. Now I'm going to add from left to right. 6 plus 5 gives me 11. I still have the plus 2. 11 plus 2, 13. I've simplified 6 times 1 minus 1 times negative 5 plus 1 times 2 down to 13. So much easier to say that way. Alright, so here we have 4 times negative 1 squared plus 3 times negative 1 minus 2. Inside the parentheses are real numbers. These are just real numbers. There's nothing to simplify, nothing to do, so we move on to exponents. The negative 1 is squared, so I square that. The 4 is not squared. The 4 is not inside the parentheses. Negative 1 times negative 1 is a positive 1, and I left the rest of the problem alone. Only took care of exponents in my first step. Next I'm going to multiply. 4 times 1, 4. 3 times negative 1, minus 3. And my negative 2 hanging out. Now I add and subtract, going left to right. 4 minus 3 is 1. Still have my minus 2. 1 minus 2 is negative 1, the simplified version. Simplify each expression. Here we go. Now we have something in parentheses. So 2 minus 5 is negative 3. Everything else remains the same. Ugly looking 3, but I promise it's still a 3. I took care of parentheses in my first step. Now I'm going to take care of exponents. 2 to the third power is 8. So instead of 5 times 2 to the third, that's 5 times 8. Minus 3 times 2 squared is 4. So I take care of my exponents, simplify those, leave everything else alone. And now I multiply. 5 times 8 is 40. Minus 12. Minus 12, a positive 4 and a negative 3 is negative 12. And now I'm going to work from left to right. 40 minus 12 is 28. 28 minus the last 12 would give us 16, the simplified version. One more real quick here. Negative 2 squared plus 4 over negative 5 minus 5. First most important thing is right here. Negative 2 squared is not the same as if we had parentheses around the negative 2 and then squared it. In the representation here on the left, only the 2 is squared. On the right, all of negative 2 is squared. So this is negative 2 times 2, where this is negative 2 times negative 2. Alright, so negative 2 squared plus 4 over negative 5 minus 5. I know I have a negative. 2 squared is 4. Plus 4, I did not do anything in the denominator. You can kind of think of your numerator as one set of parentheses and your denominator as a second set of parentheses. When you do this, you take care of the numerator and then you take care of all of the denominator and then you'll divide. So it's almost an unspoken grouping. Take care of the numerator, then take care of the denominator, and then divide. So negative 4 plus 4 is 0. Negative 5 minus 5, negative 10. 0 divided by negative 10 is 0. Now if you get a little confused sometimes, when can I divide and when can I not divide? Remember to divide by a fraction. Right? Divide by a fraction is the same as multiplying by the reciprocal. So we never really have to divide fractions. We just rewrite it, multiply by the reciprocal. And always remember, we can never divide by 0, but we can have a 0 in the numerator. That's in our last example. So NO, no zeros in the denominator, but it's okay if there's a 0 in the numerator.